Hello class, welcome to the video that I've put together for you all to work on while other people in the class are taking their test. So I said that this activity was going to be starting our new unit, which is going to be about circuits. And so this video is going to kind of give you an overview of what we're going to be talking about and kind of give you some introductory information that we're going to need to be able to complete this unit. One thing that I'm going to do slightly differently this unit is that a lot of, actually all of our content is going to be provided in a flipped classroom format. And for those of you who are unaware, I know that there's at least a few teachers in the school that do flipped classrooms. Basically what's going to happen is I'm going to make these videos for you that are going to be your homework each night. So this is what you're going to do at home, and then when you come to class, we're going to either be going over these videos or doing demonstrations in class that relate to what we talked about in the videos, or I'm going to be giving you your homework packets and you're going to be working on those homework packets in class. Now, one thing that I'm going to do to change the point system a little bit when we have this flipped classroom is I'm not going to be giving you points for completing those homework packets. Now, because we're going to be doing them in class, I'm going to be expecting you all to be completing those homework packets, but the way that you're going to be earning points in the homework category is going to be by proving to me that you have watched these videos. The way I'm going to do that is I'm going to have a small quiz at the end of each video that's really easy to do if you've listened to the whole video, but maybe it will be a little bit more difficult if you haven't done the whole video. Now I know some of you maybe are just going to look on your friends and copy down what they have, and I really don't have a way to stop that from happening, but I really want you all to stay up to date on these videos, be able to watch them before we come to class and are discussing the content that what's covered in these videos and are doing homework problems based on the material covered in these videos. These videos are really something that we're going to need to do before you all can come to class and actually use the time appropriately to do these homework assignments. So the way it's going to work is if you complete your quiz and you listen to the whole video, you complete your quiz, and I check it in class, and you get it, and you have that quiz done in class. When I'm checking it and when it's due, you're going to get 5 out of 5 points. Now, if you don't complete these homework assignments on time, but you still get the videos watched and these quizzes completed before the test, I will still give you some points. But I'm not going to give you all the points. So if you get it done before the test, you get 4 out of 5. So this is how I'm going to be assigning points for the homework component of this chapter. Now obviously we're still going to have labs that are going to be different, and then we have the exam that's going to be graded the same way with the same retake policies. So with all of that background, let's go ahead and get started and talk a little bit about circuits. So this introductory lesson is going to serve as a background to just teach us the notation, the technical writing notation that we use when drawing diagrams of circuits. So before in class, if I was drawing a diagram of a circuit, I would have my battery with some terminals. We'd give those terminals positive and negative, and then we'd bring them out. They'd be attached to our beautiful light bulb that would be shining. So this is the way that the circuits looked in the last chapter, but when you're talking about something that physicists use, you've probably learned by now physicists like to be very precise. So this is not the way we're going to be dealing with circuits. A circuit in physics is going to have a very strict look. It's going to look something like this. And so the 4 components of this circuit that we're going to talk a little bit about today are going to be the voltage source here, the wires that make it up, the resistors, and the switches. So this circuit is what we're going to be talking about. We're going to break it down into those 4 components. Now, on the last slide, I mentioned that scientists like to be really, really precise, and we want to, when we draw something, we want to draw it the same way every time, and so there's no ambiguity about what we're talking about. And one of the biggest areas that we see that is if, we tried to draw pictures instead of these diagrams for circuits, the battery sources, the voltage sources, are going to look different even though they do the same thing. So there's some batteries that look like this, that are like 9-volt batteries. There are some batteries that are like car batteries that look a little bit different. Then we have like, you got like AA, AAA batteries that look like this, or maybe you have, like a watch battery that's just a disc. So there's a lot of different ways that you can draw a battery, but if you're trying to draw them in a circuit, you want to use something that's a little bit more standard. So you saw before that in our circuit that we had this two-lined object, this two-lined diagram that we used for our voltage source. So then we had that come around and attached to other things. So this two-lined object is what is the standard way that we talk about a voltage source. The bigger line is going to be your positive terminal. The shorter line is going to be the negative terminal. Now, this is actually a very specific type of battery here. This is called a single cell battery. So if we saw something that looked like this, this would be a 4-cell battery. As you can see, there are 4 individual little pairs of lines, 1, 2, 3, 4, and this would be analogous to, let's say, look at the back of your calculator. On the back of your calculator, you'll see 4 AAA batteries. This is how you would draw that in a system. So if you just have one voltage source, you're just going to draw one parallel set of lines, one bigger, one shorter. And if you have a bunch of them connected together, you'll draw them all next to each other. Still, in this spot, you have your positive coming out of the left-hand terminal, and the negative is going to be coming in to the right-hand terminal. Now, wires are the most straightforward part of the diagrams that we've worked with before. So before, we had our battery, we had wires coming out, and they were just these kind of squiggly lines, because, in general, wires are pretty squiggly. You can bend them around and anything like that. But in a circuit diagram, you're going to be a little bit more exacting with these lines. So what you'll do is you'll have your voltage source, and they're going to come out at right angles from everything else. So maybe they'll split multiple times, but all of these angles are going to be at right angles with each other, so everything looks nice and neat and orderly. So you can see that when we are working with this, we have this right angle coming out here. You see this is a right angle, and then it comes up to another right angle. So all of these lines are nice and fairly straight right angles, as opposed to this loop over here in what we were working with before. So this is the way we're going to draw wires. The next thing we're going to talk about is going to be resistors in a circuit. Now, previously, whenever we were talking about resistors, if we were actually talking about a physical component of a resistor, I drew out what the resistors look like. Remember these kind of pill-looking things that have different color stripes on them that indicate what exactly the resistor is going to be like. We also occasionally would use a light bulb, so we would just have our wire connected to something that looks kind of like a light bulb, but because light bulbs basically work from the high amount of resistance in them, light bulbs in a circuit are going to work a lot of the same ways that a resistor is. However, when we're drawing scientific diagrams, our resistors are going to look slightly different. So if we take our voltage source and connect it up with some wires, if we wanted to then connect those to a resistor, we would draw this squiggly, almost wave-looking line in between. Now, this squiggly line is what we would use in a circuit to represent the resistance. Now, this resistance is going to be measured the same way we measured it in our previous circuit. So let's say we just say that this resistor is 50 ohms. Then we could also, on our diagram, write, oh, this voltage, we know that this is 5 volts. So why don't you all take a moment and figure out what is the current flowing through this circuit when we have a 50 ohm resistor and a 5 volt voltage source. Remember, we use Ohm's law, V equals IR. We have a voltage, we have a resistance, and so we can plug these values in. 5 equals I times 50, divide both sides by 50, and we end up with I equals 1/10 of an amp. You might want to pay attention and remember this diagram and this problem for something later. Hint, hint, nudge, nudge. The last part of the circuit that we're going to talk about is going to be a switch. So before we've talked about circuits and we've said, you know, we'll have some amount of charge running through it for a certain period of time or something like that. And we'll deal with time a little bit, but what a switch is it allows us to turn on or off a circuit. So think of a light switch. A light switch is a switch that turns on or off the lights in your house. Now, I'm not going to take the time to draw a little panel with maybe some screws in it, and then you have your light switch in the middle, and it's in the off position, but there's got to be some shading on it. I'm not going to take the time to draw a light switch like this each time I want to draw a switch in my diagram. So what we're going to do is draw a diagrammed switch. So if we, again, work with our simple circuit that we have of a voltage source and a resistor, and if we just don't connect these wires, then that indicates to us that this circuit is not on. Because remember the two things we need for a circuit to work. We need to have a voltage source and we need to have a continuous wire. But here, we don't have a continuous wire. But because it's a switch, we need to have the ability to turn it on. So our switch is going to be open like this. That means that we could theoretically throw this switch, we could close this switch, and then our electrons would be able to, actually our electrons go the other way, our electrons would be able to travel through the circuit. But when it's open like this, it is not able to have a current flowing through our circuit. So this is how we draw switches in circuits. So that's how we diagram circuits. We have to have our voltage sources that then lead to wires that connect resistors, that then, if there's a closed switch, which is not what I drew here, that can go back to our N. So voltage source, wires, resistors, and switches. Proceed to the next slide, and we will take this little quiz about this lesson. So here's the quiz that I'm going to have for this particular lesson. Now, as you can see, there's 3 questions, so not a lot. Your typical quiz is not going to have more than 5. And also, these questions are really easy, especially if you've watched the video. Now, it might, you know, if you didn't watch the video, it might be a little bit more difficult for you. But if you watch the video, these questions are going to be very, very simple for you all to do. This is just a way for us to hold each other accountable. You are holding yourself accountable, and, you know, did I do the quiz? And yes, I did. That means I actually watched the video, and I also am holding you accountable with points, saying, did you watch this video? Are you keeping on top of these things? Because you can't participate in classroom discussions and classroom work time if you've not watched the video yet. So go ahead, take a second, fill out the sheet of paper I gave you. There should be a sheet of paper that has a spot for a quiz for each lesson in this unit.